And now you try like the
We'll have more devices coming up too.
What year you are?
I read an article putting Android systems in cars. To do complete car wash.
Oh, you're not.
Changes.
Yeah, I'm gonna make your actually. Oh, you're both?
Adjusting the seat.
everywhere.
Oh, wow. Yeah.
All right, that's great.
I mean, that makes sense. I think I knew John, so I knew Grace. I love that kid.
Yeah.
I knew John and
Yeah, it's not standard.
Yeah, right.
That's for standard.
Oh, my dad is getting something like that. He already has it for the temperatures in the house. All the time.
I would say it's a good idea. It's not that hard to do. Just have a real wireless.
Yeah.
Oh, to buy shoes. Receivers and shoes. Pop on thing.
Yeah.
Wireless switches. You can see if you walk through the house, you see these little receivers everywhere. Okay, wash your shirts and like that.
I knew my roommate needed that.
I found my parents just got an iPad and they got the Xfinity app, and what they can do is they control the digital cable box from that app, and they turn it on and like change the channel like break
So I got a great show and she's
on
like,
the
yeah,
schedule
look
when
at
the show.
Yeah.
That's
Like,
really
yeah, so it's pretty easy. You can use your phone to control certain
guys are last week.
Yeah.
I don't want to.
Oh, because John's
John's like, it's going to run all sorts of applications. It's like,
yeah.
you're fully relying on that.
Yeah,
I was going to say, you could get really hurt.
And your TV is just a gigantic monitor. So they all have connection. Oh, yeah.
Can we start like going up?
Yeah.
Yeah.
No, I think it'll really work.
It's just like, you know,
His red light's a lot better. Really cute.
yeah.
This is mine, right? Okay. All right. So who did not succeed in getting the Android thing installed? One. Only one person. Good. I'm sorry, but good. One thing that apparently is a little bit misleading in the book is that I find that you're better off not installing all the different versions of Android because that's a lot of stuff. So even though I installed one version, I think you can get away with the one we'll be using is 2.3.3. Yeah, just because I have had problems with 3.0 myself, and I didn't really want to bother to go research that because it didn't matter for my purposes. For the purpose of your apps, of course, you're welcome to use the latest release version, but that's what I'm going to be using for the demo. So what I'm going to do is more or less do the homework again with you guys watching, and then sort of comment and explain some things that might not have been totally clear to maybe some of you, and use that as a way to talk about other stuff, okay? So everybody who has a computer, you're welcome to follow along with me or just watch. But basically, let's go create a project. So File, New, Android Project. And immediately you get to fill in a bunch of information. Here's where you pick the version of the Android target you want. And the reason this matters is later on, when you run the emulator, it's going to want an emulator with that version. Another thing that's interesting is if you notice here, there's an API level number here, 10. So if you want to make sure that this thing only is runnable on devices that have a certain version of the operating system, then you put the number here. Now, depending on how clever you are, I guess, you can determine that your app works just fine on a lower version and make it be usable by people with older or less up-to-date telephones. You give it a name. We'll call it Hello Brandeis. I probably have one like that. No, I don't. This is going to be used for the directory, as you can see over here. And the directory is sitting in the area of Eclipse that it knows where the workspaces are. And I'm going to give it a name. And I'm going to put the initial activity, I'm going to call it welcome. Okay, let me just check my notes here. Anything I want to mention? Okay, so I'm going to finish this. And it should be created here. And you'll notice, and I'm going to give you a much more detailed tour of the directory structure. It's very critical. The directory structure here that was built by the Android development kit is something you shouldn't mess with as far as the top level. You can add subdirectories.
Sorry, what were the create activity and min SDK version? Bottom of create.
What do they mean?
No, just what did you put in?
Oh, I put Hello Brandeis, and I put, I think, 10.
So do those, what do those mean?
I'm going to spend more hours than you want on what an activity is. So let's set that aside. I'll get to it today. And then the min SDK numbers is basically used by the Android system overall to make sure that apps that will not be able to run on a certain device don't get loaded onto that device.
Okay, so should I just do that blank for now?
No, put the number of the SDK number, the SDK version you picked. So there's like a number, I think it's 10.
Yeah.
Okay, so use that. There was a question? Yes.
What about the package?
Okay, the package is going to be used by the code generated. Okay, so it's going to generate a whole bunch of code for you, and that's just a Java package. And the reason I gave it that strange name is because there's a convention with Java packages that you name them with a domain, like an internet domain name, like brandeis.edu, but backwards. So edu.brandeis and then dot other qualifications. The convention came from, the edu.brandeis part came from what may be a fantasy, I don't know, but it's a tradition that has to do with ensuring that there's some degree of namespace collisions that are avoided. So, you know, if you call it edu.brandeis and they call it edu.harvard, right off the bat you're safe. I think that may be kind of a, you know, but it's a tradition. So that's how you do it, and then you put some more qualifications depending on your project. So the code that's generated will have that structure as well as the directory structure that's generated will have that structure. So, yeah, mine was edu.brandeis.hello Brandeis, I think. If you look here, the code that was generated by the system has one file called welcome.java, and it's in that package that I stated. And if you go to Window, Show View, Navigator, you'll get a new tab over here. See it? Oh, by the way, what's the magic to go to reverse video?
It's Control Option Command 8.
Control Option Command 8. Is that any better?
Yeah.
Better? Yes, it's harder for me, but I'll deal. Anyway, so you see here so I have now the navigator, and with the navigator you can actually examine the directory structure. So if I go here, I will see here a directory called source, subdirectory called edu, subdirectory called Brandeis, subdirectory called hello Brandeis, and there it is. And that's exactly the same convention you will see with the PA1. So the package name reflects the directory, the folder hierarchy, and that's just part of the way the whole Java system works.
Your activity name is welcome?
Yes. Anyway, but I'm going to go back to the package explorer, which is a little bit clearer. It's very similar, but it sort of digests or sort of summarizes it a little bit. Okay. No other questions, right? So let me just go back here and see. Okay, so the next thing I want to show you is I can just run it and see what happens. So the way I run it is I go to, what I generally do is I go here, I right-click, and I say Run as Android application. And you see down here, and the emulator is a program that runs on Mac and Windows and everything else, which pretends to be an Android device and is able to execute Android applications. And this looks like it's launched a 3.0 emulator, which is interesting because it just picked the latest. Now, I don't want a 3.0 emulator, so I'm going to exit from this. Oh, by the way, I think I know it's 3.0 by the look, but also by the fact that it says 3.0 up here. I'm going to quit this, and I'm going to go to, I think, right-click, properties, maybe? Let's see. And I'm going to go Android, And okay, so it says that's the build target. So now I'm going to go back. So this is describing the overall development environment as configured by Eclipse. But what I really want to do is I want to take a look at the run configurations, which is going to talk about how the Android app is launched, I hope. And if we look here, under target, we see that it's automatically going to pick one of these two, which I don't want. So I'm going to say manually, I want to. Now, I don't even know why 2.3.3 does not appear there, so you can watch me try to figure that out. I thought I had one, but yes, let's try that. So that's it, right? Yes. And I have one, but it's API level 8.
Oh.
And it's saying that's not good.
And you said 10.
I said 10. So I'm going to go back and go into the Android manifest, which I'm going to cover in a second, but we'll jump ahead. And we're going to look at it as XML, which is always easier, I think. And we're going to find here on this line, uses SDK, Android minimum SDK number is 10. And I'm going to change it to 8, like so. I'm going to save it. And notice down here, it was very quick, but it rebuilt the application and it recompiled things and got it ready. So now, let's try it again. So I'm going to run as Android application. And now, that's the 2.3.3 look. Now I want to show you something else that I learned in some mysterious place, which is going back here, notice that you can look at details on the emulator, and you can, actually that's not what I want. This is the details on the running emulator. What I want is edit this line. And you'll notice that I have snapshot enabled, and I have device RAM size set to 1024. And those two things cause it to save the state of the emulator when you exit it, so the next time it doesn't have to rebuild it from scratch. And that's why it launched directly into whatever I was running previously.
Last night when we were making emulators, we were going through the screens.
Yep.
And there you have the WVGA 800.
Yep.
And instead of the one below that, which is like, you just click the down arrow, it said that was the generic one in the book at the time. WVGA.
Yep.
Should we be using the new default?
You know, I think this is the way I want to answer this question is to talk about self-reliance, which is to think about, there's no correct answer to your question, but to think about what you're doing at this moment, what project, what you're trying to achieve, what task you're trying to achieve, and ask yourself, what can I do, what should I do to make the task easier or harder to do? And my answer based on that is that if all we're doing is an exercise out of the book, then I would accept all the defaults that I get from the book because chances are it'll work. Now, if we are experimenting and curious what these other things are, it's a different task, then I would say mess around with that to see what it does. I think that when you build a real app, we're going to have to learn about all these settings to see which ones matter and which ones don't or what effect they have. But it is important, I think, to sort of try to keep your brain engaged as you think about using all these systems and ask yourself, what is if my goal is to get this homework done, is to get this experiment done, what is the path that's going to get me there the quickest? And what are the side trips which are going to help me or hurt me? And so I don't have a real answer to your question because I don't know, but I would say leave it alone.
Okay.
Yeah. API level? Okay, that's a good one. So basically, a system like Android or any system has a huge number of methods and classes. And from time to time, to add a feature, they have to make a change. So if I change a certain method to have a new name, or if I change it to have a different parameter, and this is in the operating system, and I run a program that doesn't know about that change, it's going to blow up, right? Other changes don't matter. If I just fix a bug or improve the efficiency, it doesn't blow up. So you need a way to try to protect an old application from the problems of a new operating system, or protect a new application, which assumed that the API had changed, from the problems of an old, from hitting an old operating system. And so to do that, this is a perennial problem. I'll talk about it more. We'll talk about it more during the class, because it applies to APIs, it applies to protocols, it applies to data formats, it applies to everything. How does my application's expectation about the universe match or not match what it's going to find in the wild? And there's really no good answer, and there's no ironclad solution. So what you find in the way these systems are conceived and architected is many different tools to try to avoid the terrible thing, which is you call a certain API and nothing goes up. And this is one of those tools, which is somebody high up in Google Android decides that a certain change that needs to be done because of new functionality, a new device, performance, whatever else, is severe enough that it's going to cause an application out there to break, and you decide to click up the application version number by 1, from 8 to 9. Now, this is a very momentous decision because it means that a whole bunch of apps that are in the market will now stop working. And it's a very momentous decision to not do it because it means a whole bunch of apps out there in the world will start blowing up. And so I would call it a blunt instrument. In other words, setting a single number to reflect the tremendous variety of APIs and formats on one platform is it's a very rough tool. But it's the first line of defense against an application which is trying to run on the wrong version of the OS. Okay. All right. So check out the enable of the snapshot and the device RAM size 1024. And if anybody comes across other ways of launching the emulator faster, please share it with us. That's one I found. Well, you make a new one, right? I think you can even edit an existing one. See, like this button here, not the details button, which is looking at the one that's running. The edit button. Yeah. Okay? Okay. So, I also found, I don't know if you guys found this, sometimes when I try to close that AVT dialog box, it doesn't want to go away. So I just exit Eclipse and start over. You know, we're working here with very, very fresh stuff. And so get over the idea that it all works as specified, because it doesn't. There's bugs, there's incorrect documentation, there's things that have changed that have not been written up. So yes, your mainstream through this morass is, read the manual and understand it and use it. But if things act differently, usually it's a bug of your own. And so usually it's like, well, I didn't change even one line of code. It worked yesterday, it doesn't work today. And then you ask enough questions, turns out, well, actually I did change that one line. Yeah, but it couldn't possibly have caused the problem. Well, it turns out that's what it is. So anyway, just one
going to the Explorer, maybe that should be
okay. So anyway, so one of the hypotheses is, yes, you may have a line of code that you change that caused the bug, and that's the likely problem. But it could be that it's a bug in Android. It could be it's a bug in Eclipse. It could be that's even a bug in the operating system you're running. So that is always an available hypothesis. And when I talk about hypotheses, when you're trying to get something to work that doesn't work, instead of hitting your head against the wall, trying it over and over again, they say the sign of madness is somebody who does the same thing again and expects something different to happen. You've heard that, right? So don't hit your head against the wall. Ask yourself, form a hypothesis. Well, maybe this is what's going on, and then test it. That's sort of a thought about testing things. So don't assume it all works as it should, and sometimes you just have to exit Eclipse and go back in, and all your problems are solved. It's true. Okay, so here we go. We got hello world, welcome. Okay, and that's what came out of this thing. All I did was I just typed it in. So we have to go find out why it is that it built this particular application when I went just through the guys, it's a little bit distracting for me. So maybe if you guys want to do this, maybe step outside. I'm sorry, just a little distracting. If you need to step outside to do it, that's okay. 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 So, all right. So now I want to make sure I point out all the things that I want to point out. Version, package name, and its activity. Okay, let's talk about activities real quick. An activity is a very important feature. Here's an article. Here's a little diagram. And here's a diagram I made before we started. So the reason, the thing that's weird about Android from any other system you have used is that an application is built of all these little separate building blocks that are glued together and can be glued together in different ways. All right. So for me anyway, from my conception of the system, one of the very basic building blocks of the UI on Android is this thing called an activity. And at a very simple level, an activity is a screen. Okay, so an application has a bunch of screens like this. This is my dummy iTunes application on Android. The first screen shows me a list of songs. I can click View, and it'll take me to a picture of the song that I'm looking at. I can hit the back button, and it'll take me back to the screen I was looking at. It's very simple. There's nothing deep here. I can hit the delete button. It takes me to this screen. Are you sure? Yes, no. I can hit back to go back here. Or I can say yes, and it'll say deleted, and I hit OK, and it takes me back there. Okay, very simple, simplistic. This app has 4 activities. 1, 2, 3, 4. Okay? Each activity is managed by Android to be created when you tell it to create it, to be stacked on a stack as you navigate through. So if we took this path, because remember there's a back button on your Android, right? That's always there. So if I went to click here, hit delete, hit yes, and over here I said back. At this moment, there will be a stack that shows, let's call this song list. Are you sure? And deleted. There'll be a stack of song list, S list. Are you sure? And deleted. Very obvious again. And all these classes, because an activity is a class, you'll see that, I'll show you in a second, how when you create an activity, it is code that's generated by the Android SDK, and it's going to be a class that's derived from Android activity. And as you move your way through, it creates the stack, so when you sit back, say back on the hard or soft button on Android, because the Android operating system, as far as I know, they're always changing things. There's always a back button either on the screen or on the device. You hit back, and it takes you to this and to this, and then you can't get back anymore. In fact, when you launched this, there was the, I don't know what it's called, the Finder that had an icon on it, that when you click on this, I'm breaking my own color code. It went here. Anybody know what the name of this thing officially is on Android, the Finder, where you have the icons? There's a term for it. Forget it. Okay. Pardon? Application launcher, maybe. I think it's the app launcher. So in fact, the app launcher is sitting down here.
Mine says applications.
Just but I mean the class name or whatever. You know what we're talking about, the thing where the icons appear. Now another thing that's really crazy about the Android is very different from the iPhone. First of all, the presence of the back button is very different. There's nothing like the back button on the iPhone. And the back button, the fact that it exists and the fact that the scheme with activities exists is going to influence a lot the way you structure your application. Okay. Another thing that's strange about the iPhone, about the activity scheme, is that, and the reason that it exists, is that activities can be mixed or used by different apps. Typical example is if your app has a button on it that says call this phone number or make a phone call, which you can do. It could be my Brandeis application that says I want to call the dean's office. Hit a button, or I want to call some number. You can actually cause it to display a list of names in your Android's address book, and you can let the user pick one of these names, and then you can return back to your app, to your Android app, your Brandeis app, and do something with that name. So in other words, you can display the list of names that are that is the activity which by default is part of the phone book app on your Android. You can literally invoke that. Moreover, here it gets even crazier. You can go out and buy a new phone book application better than the one that came with the Android, and it will have a pick a phone number list. And if the user installed that on their Android, when your app said, I want to look through the list of names, it will launch the new phone book. Okay? That's just one example. So the principle here is that the activities, while they form loosely together your application, in fact, depending on the scenario, they could be reused by other applications. And that's very powerful and very unique. So for instance, like on Apple, if I want to do the same thing, I basically am either copying and pasting or doing some other operation, but I'm not really able to invoke the address book, the regular default address book from my app if I want to pick a name. And there's examples with taking pictures. If I want to be able to take like a profile picture, again, in Android, I could launch the default photo camera app on my phone, and whatever it is, I could use it if I wanted to take a profile picture. And that's a very powerful idea, and that's, in my way of thinking, kind of led to this scheme, because the second concept I want to tell you about is this thing called intents. An intent, think of it this way, the user has an intention to pick a name. That's the intention. So that intention actually gets a symbolic name within the operating system. In other words, when I click on the button that says pick a name that it meant to lead to the display of the list of names, the way that link is made is by creating an intent object that says, I want to pick a name. And Android then will figure out from that intent object, and we'll cover this again, so this is going to be a little confusing at first, but I'm just giving you the tip of the story. This intent will then lead to Android figuring out what is the current default list of names to display and display it. Moreover, when you hit OK or whatever the command is on the list of names, it'll take you back to your app that's running. So you end up with something like this, and this is I won't even try to read it, but the map of the way your activities flow from one to the other is a key design consideration. And so as you're thinking about how your app is going to get built on Android, a very fundamental step to take is to make a diagram like this. And to be very, as you go through it, be very, think of it as programming. Be very precise, like I was. This button goes here, this back goes there, because you'll find if you try to draw all the lines, and I'll have folks do that at one point to draw all the lines, you'll discover, and we never really thought about what happens in this case. So this is almost like a visual functional spec you have to do. And this is an example for another app. So you end up, sometimes you can hop over something, you can go back, there's loops, whatever. It's just a graph. But thinking through that is going to really help you understand what's going on. Another thing, so here's the thing about intents, which I won't go into, but there's a whole chapter in the. By the way, the developer.android.com, very, very rich resource to look at with all kinds of APIs and stuff. Yes.
Can I ask something about the activities?
Yes, sure.
So you mentioned something about the activity stack.
Yeah.
So you can keep pressing back.
Yeah.
That refers to all the different applications, right? So if I have like navigation open and I'm viewing my pictures,
right?
My pictures and I hit back, will also take me back to the navigation.
Yeah. Yeah.
So that activity stack incorporates all the applications.
Right. And by the way, I call it a stack because that's kind of the starting model to think of. But there's all kinds of ways to play around with that stack. Because sometimes you want to make it hop. Like if the user hits back here, I really want to go directly. I don't want to go here and then here. I want to go directly here. You can do that. Okay. So it's like the default way to think about it is a stack. But then when you have other requirements, you can tweak it. So and intents then, the way to think about intents, it's a class you can instantiate, and it's just kind of a pointer to another activity. But the pointer has the ability to bind itself to something that exists today that might change tomorrow. So it's like a soft pointer. Okay. All right. Now let's look at the directory. Let's go back to the code. So let me give you a little bit more of a walk through the code. So take a look. So the only Java that was generated by this SDK is this, and you notice that it's in the package that I described. It imports the Android library called activity, and it defines, it actually subclasses the activity class from Android, And there's a whole list of methods that are permitted within an activity. And this sort of points out how on Android, like any of these special devices, and on all these systems actually, you're not really in control of the CPU. Your code gets called when things happen, and you're supposed to do things about them. You get called because your activity got instantiated on create, so now it's your time to instantiate yourself. There's another call, and we'll go into greater detail about this. You got called because the activity is about to be killed. You get a chance to do something about it. So you have a list of methods to implement, but the minimum one is on create. And so the first thing and only thing it does is it tells the activity where to get the content to draw here. And everything that's drawn on the screen is a view or a subclass of a view. So it's saying the content for this activity, the Hello Brandeis activity, is this view. That's not helpful. And it's called the main view up here. But notice that it says r.layout.main. Okay, it's a constant because that view was actually created from XML. And a big principle that you'll see is throughout the API, throughout the SDK, is that a lot of things that determine the look and operation of your application are specified as XML. Okay, so r.layout.main is a resource of the type layout called main. Now, this directory called gen is full of stuff that you don't need to, you shouldn't change, you don't need to look at it. It generally doesn't matter. Where you want to go is the res subdirectory. In the res subdirectory, you'll find that there's a bunch of further folders of different types of resources. And the resources all have this more or less standard look. So if I go in here, here's the resource, which is a layout, and it's called main. Okay? If we look in here, we'll find, and I usually skip the graphical layout and go right to the XML. It's a very simple layout. And basically, we're seeing here the beginning of the tools you have to construct your activity. Because remember, an activity is taking over the whole screen, and it's being controlled, the layout of it is being controlled by the views that are displayed. So this particular activity has a view that is nested. The top level is a linear layout, which is one rectangle after another, or one rectangle above another. In this case, it's vertical, so it's one rectangle above another. And inside those two rectangles, there is in fact, no, there's only one. It could be one above another, but in this case, it's a vertical layout with only one thing in it, which is a text view. So what we have basically here, in this case, is there's the vertical layout, and in it, nominally, although I'll show you why this is not exactly true, is a text view, and in here there's a piece of string called hello Brandeis. Okay, so you have an outer view, which is creating a vertical layout, and an inner view, which is having some content. That's the basic principle you see elaborated in gory detail. So let's look a little further, and we'll see here that it says Android, so the value that's being displayed in this text view is @string/hello. What does that mean? What it means is that if you look in the value directory, under res, you'll see a file called strings.xml where resources of type string are stored. If we look in here and we go to the XML, you'll see very, very minimalist that there's two strings. There's a string that's called hello, and there's a string called app name. The hello string is the word. Can you read? Is this font big enough? Yep. Anybody? Okay. The string is hello world welcome, and the other string is hello Brandeis. But the one we want from the previous one is the string called hello. So we look here. String called hello is the notation is @string/hello. Anybody tell me why I don't just put the string, the hello, how you doing right here in this place instead of putting it in the string over here? Notice, why don't I put hello world welcome right here? Why? When?
Always computer science, so the idea of computer science is to make layers of abstraction. And so if you're going to write out what the string said exactly in your
Layout, yeah.
layout view,
Yep.
that would be counting it right now and string size are also the actual function.
Anybody else? Yeah?
What if you wanted to change the string and you have that string below and one on one?
Right, so reuse, yeah. And the biggest reason of all? No. Anybody whose name has two things on it will know the answer to this. Internationalization. So I can have an English and a German version of the product. I can just replace this string with the translation of it, and magically the app will be talking a different language. In fact, the way it works is that you can have multiple of any of these XML files that are chosen automatically at runtime by the Android device, depending on the language of the Android device. Okay, so if the Android device is set into Portuguese versus set into German versus set into English, it would select among these files. The other really powerful thing about it, of course, is that the people that are linguists are not programmers. And so to have them go fishing around all over the place for strings is a pain. You could give them something like this or even something simpler. They can just translate it, submit it to the build, and out comes the version of the product that can now talk in the language. And that's really the most critical reason for having the separation of the strings from the code. But it actually would work just fine if you wrote the string in here, except you'd have bad structure, bad architecture. Okay?
So we should probably try to internationalize.
Yes. Yeah, absolutely. Yeah, I mean, so this is something.
Easy to do.
Right. Yeah, absolutely. I mean, and if you follow this principle, and you should, of separating the strings, you have it's very, very straightforward, and it's amazing. Now, the funny thing is that this same mechanism is also used to deal with, as a tool to deal with different kinds of devices. You can also have it pick a different layout file, not based on the language, but based on the size of the screen. So it could automatically say, I want this layout for a screen that's portrait mode and this other layout for a screen that's vertical. So this same mechanism is used for a lot of different ways where the UI wants to dynamically react to a change that's happening on the device without forcing the developer to do a lot of coding. Now, the other thing that's interesting I want to point out is that the reason, now you could obviously, well, not obviously, but you could have simply drawn saying I want this text string at this coordinate on the screen and that text string on that coordinate on the screen. But the problem that brings up is you don't necessarily know what kind of screen you're running on. High res, low res, big screen, little screen. And so by deferring the layout heuristics to an algorithm, essentially, you give your app a chance to look reasonably well on a device that's different. And I qualify that with a chance and reasonably well because often the heuristic can only do so well. And you find that if you turn the phone this way versus that way, it looks kind of bad. One thing that is different, so in general, the rule is test your application, that's why we have different devices, on different devices and see how well it does. Don't assume portrait and small screen. Don't even assume on Android that the initial screen is going to be vertical. On Mac, on iPhone, you can assume that the initial screen is going to be vertical if it's a phone. I don't know what probably also with an iPad because the button is there and it sort of dictates what the bottom is. But on Android, you can't make that assumption, and so you need to think about it. So you get a lot of free ride on the appearance of your UI from these automatic heuristics of layout, but when you test, you will discover, well, okay, I can read the screen, but it looks really bad. And then you may decide to have a specialized layout for that. Yes?
I just wanted to comment also that this XML stuff just gets compiled straight into Java.
Right.
You look at the source thing to see it. And in fact, there is a linear layout method, and there is a text view method. And if you want, you can just write all in Java.
Exactly.
Use the XML at all. But it's nice to have it there with names.
Right. Yeah, exactly. And also you get all this automatic flipping around business. But it's very true. I mean, if you looked at this welcome.java, you see this magic method called set content view with a parameter, which is, let's see if it shows up. A layout, it's not actually type checked, but if it's an int parameter, it's going to know that what it's getting is a resource which is going to have to be translated into the right calls. So you could literally go create a view, put them together in a vertical layout, all that in Java. And sometimes you have to do that, but by and large, avoid it at all costs because it's much more productive the other way. All right. Okay. Now, okay. I want to jump to this. I'm obviously going to way too much information here as usual, but that's always better. So I want to show you this diagram that's on the attachment area of this particular page in our website. Okay. And here it is. And basically, this is a diagram to help you understand all the interdependencies between these things. And it's once you get it, it's very straightforward. But if you know, at the beginning, it could be a little complicated. So, so know that a diagram is there, and check it out when you get lost about where things are. I basically said, you know, each file, I took a string out of the file, and I said, okay, that string actually came from here, and that string actually came from there. So that's how you can see how these things are connected together. But let's continue on this code. So now let's test all the nonsense I've been saying and see if it's really true. So first of all, we look here and we say that we see that the string says "Hello world, welcome." And of course, if I want to make this, okay, let me do it this way. Somebody who hasn't spoken yet. If I want to make that message be something else, what file should I go look at? Okay, and what do I do here? Right. Hello, Brandon. Okay, and I do this. If you look here down here, whoop, see this? It quickly compiled that XML file, put it into the compiled form in this generated folder right here. And there's the string, and there's the hello string. So it's compiled this, and if we look at this, there it is. So it's changed this into a string, in this case, with a number, and somewhere else. So here the r dot app name equals this, and somewhere else, which I don't know offhand, but we'll leave that for exercise for the reader, the actual text of that string can be found. You don't have to ever look at this file other than curiosity, because this file, this gen file, is generated by the platform. By the way, if you have very mysterious problems with getting things to run, try doing this. No, not that. Project clean, which basically deletes all the .class files and all the generated stuff in the res subdirectory and regenerates them. So sometimes that's a way to get you out of trouble. Okay? Now, we're going to be out of time in a couple of minutes, so I want to point out something else. Notice that I talked about this. Let me put it on the screen. I talked about main.xml. Here's the layout, that there was a container. Notice that this is inside, this text view is structurally inside of this linear layout. Does everybody have a kind of a reading familiarity with XML, or does that deserve a little explanation? Anybody?
A little bit, yeah.
Okay, good. So basically XML is, as you can see, yes? Yes. No? I think I can do this. That's my trick. Control and two-finger tab. Okay, so you can see it now. So basically, XML is a format that is used for a gazillion different things. And it's a textual representation of nested data. That's what it's for. Okay, and the structure is like this. There's a series of things they call tags, which are angle bracket, and a word. And the way you create a nested thing is by having an opening tag and a closing tag. So in this case, you'll see here, linear layout is the opening tag, and / linear layout is the closing tag. So it's creating a container in which there's only one item, called the text view. The text view, interestingly, has the word, ignore these green things for a second, and then the / bracket right there. So in other words, there's two ways to make an opening and closing tag. One way is like this. Name. So this creating an object, an XML object called name that has this in the body. You can nest it more typically. You could say name first. Email slash first. Okay, this is still valid XML. And now I've created essentially like a data structure. I can do last, salad, slash last. Okay? Now the other thing you can do is add properties. So you could say, I forget the exact syntax. I'll ignore those things. So you could say, oh, I don't know, public equals yes. So what I'm creating a property here, and the syntax of XML is standardized. In other words, the use of angle brackets, the use of slash angle brackets, but the tags, what are valid tags, are not standardized. They're available to you to decide what you want to represent. So whatever the purpose is, you can put whatever you want. But the beauty here is you have a totally standardized format for structured information in text. Why text? It's human readable, right? So I can look at this, and yes, I can create a fancy schmancy graphical layout tool that just reads this text and renders it like that, but except it doesn't really work that well, so I don't use it usually. Or I can do it in this form and then just work on text. So it's just a structured way to represent data. It's hierarchical. There's often, as there is here, a preamble at the top, angle question mark XML blah blah blah. That tells anybody trying to process this file that it's using XML version 1, and the character encoding is UTF-8. Character encoding has to do with how the bits in the file get turned into letters. Okay, UTF-8 is like good old-fashioned ASCII almost, but it allows a file that's generated in a country that has a different character set to still interoperate properly. So you can read, at least read it. You can at least tell that it's in a different language, and if you can understand that language, you can process it. Generally, the first line, that's just boilerplate. It's always the same. So you don't have to worry about it, but that's what it's there for. Finally, the one last thing I'll say is, let's say that the name, so in this case, yeah, let's say that instead, all I wanted to say was name, public, no. And since it wasn't public, I'm not going to put anything else. Then I have to add a closing tag here. So this becomes a well-formed sentence by itself. In other words, if I say name by itself, and that's the end of the file, the whole file, that's invalid XML. You have to have a slash name on there. And that's a little bit of XML. There's a lot more to it, but that's really what it is. So mainly, it's very, very simple and easy to understand. So in this XML, you see now that somebody has gone and figured out what the syntax is for this particular XML used by the Android SDK, and it involves these different tags. And notice that, so to go back, so that this text view, by the way, was there the XML explanation okay? Everybody get it? Enough? Yes?
I understand how it works, but I don't understand why.
Okay. The why is, if you wanted to store structured data, hierarchical data in a file, in a way that people in the world can easily understand by looking at it, you could use XML for that. There's nothing deep about it. It could be like on Windows, there's .ini files, .ini files, they have a certain format. We haveplists on this. It's just another format. This happens to be a format that's very, very universal, used on a lot of different systems. Okay?
And also, there are parsers that will parse this kind of stuff and convert it into whatever form you want. And before they had this, everybody would look up their own form.
Exactly, yeah.
Right? And it was just crazy. You have to read something from somebody's file, you have to figure out what their parser was.
Right.
How are they going to quote characters? What kind of character terms can you put in?
Exactly. I mean, look at any files. I mean, you know.
Now you can read anybody's.
Right.
There's a thing called a DTD which says what the grammar is.
Right. And amazingly, not only is there's even hardware. It's so standardized you can buy a piece of equipment to parse it even faster. So once you have that's the beauty of standardization. Once you have a standard format, now suddenly all these other things can go on. All these other things can happen. You can build hardware, build efficient open source algorithms. You can interoperate and send data back and forth.
And it seems inefficient because it's very wordy, but if you run through a compressor, the compressor takes away all that transmit it zipped or something.
So this data structure, that, and I'm going to wrap in 92 seconds, so I am looking at the clock. I know some people are nodding off. So this data structure basically is that this view, no, I didn't mean to draw it this way. I meant to draw it this way. This view, called the layout view, whatever it is, contains one thing, which is the text view. That's very simple. It could contain more things, but it contains one thing. The layout view, which is actually, to get the right word, is actually the linear layout, is saying, here's a set of things which I want to put in a row. And furthermore, it says, I want to put them in a vertical list, so in a column. And the list of things happens to have only one thing in it. That's this thing, text view. It further says, the text view says, I want to be as wide as my parent, okay? And I want to be only as tall as needed for the content that's in me, wrap content. There's a whole list of these. I'm just giving you these. So this text view is going to be as wide as the parent, as wide as this guy, and it's going to be only as tall as it needs to be to accommodate the text that's there. Okay? Furthermore, we see that the linear layout itself has two parameters that say, in both cases, fill the parent as big as you can. So what's going to happen is, the area to fill is the screen, it's the whole activity. The linear layout is filling the thing as big as it can. However, the text view is only going to be as wide as its parent and only as tall as it needs to be to accommodate the text. And that's why you end up with hello up there. Get it? And that principle of automatically dynamic layout means that if I turn the screen sideways, this box is going to get wider because there's more room and it's filling the parent. And maybe before it needed 3 lines, now it needs only 1 line. And if I put it on a laptop or a tiny device, it's going to still work. So this is what I talked about before as the heuristic. There's rules that try to do as good a job as they can. And of course, if you translated this into a very wordy language, and this takes 10 lines, it would still work correctly. So that's the basics of the way the app's put together. When you start digging into it, take a look at that diagram I made. I think it's a helpful guide to figure out how things are assembled.
The linear layout says, fill parent from width and height. Can you say not fill parent?
Yes.
Or a way to make an app that only takes up half the screen?
Absolutely. There's just a gazillion options, yes.
I've never seen that. What would it be on the other half?
There could be a spacer, because there's all kinds of margin options. You can tell it, fill it, but make sure you keep at least 3 inches. You could put another text view there that's empty. I mean, there's all kinds of ways you can do it. You could tell it to lay it on a grid. I mean, it's a very, it's quite an elaborate mechanism to give you, to avoid as long as possible, as possibly possible, the need to actually go assign individual pixel positions. Because in the end, in the final analysis, lower level in the operating system, something is saying this coordinate is 0, 0 on the screen, and that's where to put it. But you want to keep that as far away from the application code as possible to give it a chance to work when they come up with the iPhone 6 that has a different screen, more resolution, more colors. How's that? People sort of understand it? Any lingering questions? Okay. Break.
That's fine. And then, should we meet back in Bowling 101?
I think so, right? Is the network still screwed up here? Yeah, it is.
No, it's actually really good.
Really?
Is it?
Yeah. I don't doubt it.
Well, we could just stay here.
Okay.
Well, you're hot.
The ones that are good network, which network are you on? Secure?
It's like,
And the ones that are bad?
I was on open.
Open was bad?
I was just in
It's comes and goes, right? That's the thing.
I have these
Yeah.
experiences.
Shall we try this out?
If there's a life on the network, it
So wait, so are we
kills
here?
every other
Try one more week
Yeah,
and
it
then.
doesn't
We're gonna get our own little Wi-Fi.
Why don't we just try to stay here and see how it works?
Okay. You have a little Wi-Fi? We should bring the test up and see what happens.
I don't have it home. I mean, it's at
Oh, it's at
home.
home.
Okay.
I leave my stuff here.
Well,
We don't have a key yet.
That's the nice thing with Bowling 101 is I have a key.
Well, we should be able to get the key to this, right?
Um,
Not so much?